I'm excited to be here today to talk about how we can simplify application development with a converged database. Now, not so long ago, app dev for the enterprise was actually reasonably simple. Typically, a small group of developers would work on a single development platform using a single data source to build those applications. But as time has gone on and enterprises have been put under increasing pressure to stay competitive, applications for the enterprise have also become more complex. And the reason being is they need to operate on a very diverse set of data that's often taken from multiple systems in real time to be processed. And that can be everything from spatial data to document data, sensor data that maybe has to be streamed into the application. And how we generate value from that data is going to be quite different to a traditional enterprise app. For example, we may use machine learning in order to do real-time product recommendations. We may use graph analytics to be able to identify an influencer or a community. We may use spatial to be able to track products or our network. We may also need to be able to use more advanced security techniques, things like blockchain. And how we develop these applications has also evolved. We take advantage of new development paradigms like microservices, event processing, API-driven development, and even low-code development. And so this has led to a very new approach to application development, one where we're going to pick a single purpose or best-of-breed database for each of the different data types or workloads that we need to address. And at first glance, this approach seems like a really good idea because at the start of each project, we get a database that has a convenient data model that's fit for that particular purpose. And it's going to come with an API that's easy for developers to adapt because it seems very natural for that particular data model. However, even a very simple project is going to need to operate on multiple data types or even support multiple workloads. That means we're going to need multiple single purpose databases. And that has the potential to fragment our data across these different databases. And on top of that, each of the different databases will have its own unique API. Remember that API being very native to that particular data type or workload that they're going to support. The problem with that is because those APIs are unique, we may actually get locked into a specific database or even cloud provider that hosts that database. On top of that, these separate independent databases are not that easy to integrate. The reason being is that they all come from different vendors or different cloud suppliers, and therefore you're on the hook to do all of that integration in order to be able to create a solution that's complete, available, secure, and scalable. And unfortunately, that means complex integration custom code that you're on the hook to maintain. You're also on the hook to propagate the data across the different data models and databases, depending on what you need where and when. And of course, unfortunately, that propagation can introduce a lot of complexity and also delays and worst case diversions of your data across these different databases. So how do you manage this level of complexity? Well, what if I told you there was a different or an alternative architecture to the single purpose database approach? What if we were able to take advantage of a converged database, one that supports all of the different data types that we need, as well as all of the different workloads? Now, you may be saying to yourself, well, isn't that just a multi-model database? But it's not. A converged database is a multi-model database, but it's also much more than that. Because not only does it support all of the different data models and different workloads, it also has additional software optimizations and technologies built in to engineer all of those different data models and workloads so that they can work together. And that is going to make it much easier for us to actually get cross-data synergy and have the ability to run transactions and queries across all of our different data types and different workloads and be able to get a much better insight into the data that we've got stored in our databases. Now, you don't let the image on the left-hand side of the slide there fool you and think when I say converged database, I mean a monolithic database. I'm not asking us to go back in time and take up that old approach. In fact, a converged database doesn't have to be monolithic at all. it can actually be several databases, and I'll explain how that is in just a second. Because what I want to do next is take a look at how a converged database can simplify the architecture and the development of these new applications. And I want to start by taking a look at probably the most popular new development paradigm for these apps, which is microservices. And with microservices, what we're doing is we're encapsulating the functionality of a specific application module into its own service, separate from all the other modules in that application. And by doing that, it allows us greater agility because we can both develop and upgrade that particular service independent of the rest of the application. And because of that independence, it's also more highly available, because if one of the services happens to go down, the other services remain open for business because each service has its own data store that is suitable for that particular microservice. So making it really nice and simple. And Oracle allows you to be able to implement microservices very easily and simply with the Oracle database, because each microservice can store its data in its own logically separate database container that we call a pluggable database. But what's beautiful about this solution is the fact that multiple pluggable databases can be combined into one or a small number of physical databases. And what that will allow us to do is to manage many of those individual pluggable databases as one. So we can patch them, we can back them up with a single command, and we can also restore them with a single command. And what that allows us to do is have those microservices be restored to the exact same point in time. And that way we'll have a consistent view of our data across all the different services, even when we need to do a restore. So giving you all the flexibility of a microservices architecture with a lot easier to manage solution for it. Now, another popular architecture for new app development, of course, is event-driven architectures, one where we're going to capture, communicate, process, and persist events. And of course, the platform that most people think of when they think of event processing is, of course, Apache Kafka. An Oracle database makes it incredibly simple for you to do event processing inside the database, because we can stream events to and from Kafka. So you can use our Golden Gate replication to stream database changes into Kafka, and you can query Kafka queues directly from the Oracle database. And of course, event processing is not new to Oracle, because we've actually had the ability to do event processing inside in the Oracle database for decades by taking advantage of our Oracle database queues. And since those queues are built into the Oracle database, those queues can provide full ACID transactions across all of the events and have all the power of SQL at your fingertips to run queries across those events. And of course, by taking advantage of our Confluent connector, we can stream events between Kafka and these database queues, making it incredibly easy for you to be able to take advantage of event processing. Now, another architecture that's seen great popularity is API-driven architectures, one where we decouple the front end of the application from the back end, and we can mitigate any dependencies between them, therefore reducing the complexity of the architecture. And Oracle makes it really easy to be able to take advantage of API-driven architectures, because we allow you to create an API on top of any SQL or store procedure inside in the Oracle database. That's right, you can REST enable any data access inside in the Oracle database. That means your applications can access data just like they would any other service by making a simple REST API call. So not only does that simplify your application code, but it also standardizes it, because the developers no longer need to worry about how to get that data. They simply just make the call, and that definition of what that data is or how it should be generated is stored once inside in the Oracle database. And of course, we can also improve the performance of application queries by putting some of the business logic inside in the database as a Java or PL SQL stored procedure. And that way, by having the business logic inside in the database, we can actually reduce the number of round trips between the application tier and that database tier. Very similar to why you take advantage of JavaScript in a browser to avoid those network round trips. Now, another area that's really popular and very close to my own heart, of course, is low-code application creation. Because here what we're using is a graphical user interface instead of hand coding our computer programs. And Oracle makes it really simple for you to be able to take advantage of this new development paradigm, because we actually ship our own low-code development environment called Apex with the Oracle database. And what's great about that is not only is it a browser-based development environment, so no tools need to be installed, but you can start building a new application with any data that you have available, whether that's a table inside in the Oracle database or it's data that's in a flat file or a spreadsheet out on the operating system. All you need to do is point Apex to wherever that data may reside, and you can instantly begin to build that application. And you don't need to worry about the mid-tier, about connection management, state management, worrying about mapping the database types to the application types, or even keeping that system highly available or scalable, because Oracle takes care of all of that automatically for you by having the application tier inside in the database. So it's all done automatically. And because it is so easy to use, you can actually have enterprise applications up and running in just a couple of hours or days rather than weeks or months. And because the interface is so simple and you can iterate so quickly, there's no problem to have the business user actually sit alongside the developer and iterate over the application, the look, the feel, the functionality very, very quickly, so they can instantly see what they're asking for there on the screen. And that way we can actually get much greater value from these applications in a much faster time. As I said, days or weeks instead of months and years for new app dev. Now, another architecture that's been popularized mainly by the internet companies, of course, is giant distributed architectures. And they are becoming more popular, though, for the enterprise, not just for these internet companies these days, because of data sovereignty. A lot more industries are being held to very strict data sovereignty regulations. And so because of that, Oracle is going to make it super easy for you to honor that data sovereignty or to provide massive scale by taking advantage of our native sharding. With sharding, you can take a large Oracle database and break it into a farm of smaller shards or databases. And each shard, as I said, is its own Oracle database. It's running on its own hardware, which means that it can be placed in whichever geological region you need in order to honor that data sovereignty. On top of that, because each one is an independent database, there's great isolation between these shards. So if one of them should go down, the others remain open for business. And of course, because they are Oracle databases, there's really no need for that shard to go down, because we can either run it as a rack environment, or we can also have an active data guard standby. So if anything were to go wrong with the primary, we would simply fail it over to that standby. Now, in most sharded architectures, what you're going to do is you're going to change the application code slightly. And by that, I mean you're going to add the shard key to each of the queries so we can automatically direct that query to wherever the data may reside. And Oracle obviously offers that as part of our sharding. But on top of that, we also allow you to run cross-shard queries so you can get a holistic view of your data set very, very easily. And of course, when it comes to scaling, you may want to add or remove shards, and Oracle allows you to do that completely online while the application remains open for both read and write. We can fully reorganize the shards for whatever you may need to do for your particular system. So really, you're getting all of the benefits of a NoSQL sharded architecture, but with a mature SQL database. Now, I mentioned earlier on that being able to gain insights into data in real time 24/7 is critical for these new enterprise apps. So we can no longer have the luxury to be able to take downtime and patch or upgrade these systems. Everything needs to be done with continuous delivery. And Oracle makes it really simple for you to be able to do that, because we offer full online both schema and data evolution for you. So one of the approaches you can take if you're storing your business application code inside of the Oracle database is to take advantage of edition-based redefinition. This allows you to have multiple versions of your application code active in the database simultaneously, allowing you to slowly migrate users from the original version of the code to the new version, but also giving you the opportunity to have a fallback if anything were to go wrong, And this can all happen fully online. Once you're happy that the new application code is stable and ready for production, then we can, of course, obsolete the older version. Now, the other thing that people need to be able to do is, of course, adapt their schema. And Oracle makes it incredibly easy for you to be able to do any online schema changes that you want. So things like add a column, drop a column, add an index, partition a table, repartition a table, reorganize data, whatever you may need to do, Oracle offers you the ability to do all of those operations online while the application remains open for both read and write. And of course, because we offer native support for JSON and XML inside in the Oracle database, you can also take that approach where you store all of the data in documents. And that way you can rapidly change the schema and evolve it without any delay inside the database at all, because you'll simply just have new entries or elements in those newer documents stored inside the database. And if you're worried that this may not be tried and tested capabilities, let me assure you that all of the Oracle application teams that are offering SaaS services that need to be available 24/7 are taking advantage of these capabilities, as are a number of our customers that are also SaaS suppliers, folks like Salesforce, for example. So let's take a look now at how a converged database can simplify creating value from data in new ways. One of the most common ways to create that value these days is to take advantage of machine learning. And Oracle makes it really simple for you to be able to do that because we have over 30 in-database parallel machine learning algorithms built right in. And they'll allow you to do things like real-time recommendations, fraud detection, or even sentiment analysis. And by having them built into the database, we're actually going to eliminate a lot of the cost and the risk associated with moving large volumes of data to the separate machine learning engines. We like to say we're bringing those algorithms to the data rather than the data to the algorithms. Now, for a lot of data scientists, they much prefer to operate in R and Python, and we have full integration with both R and Python to make it much easier for those data scientists to be able to use the database as a high-performance compute engine for that machine learning. And of course, you don't have to be a data scientist to be able to take advantage of machine learning inside in the Oracle database. For us novices out there, or for data scientists who are looking to accelerate their particular model creation, you can take advantage of AutoML, which is a no-code user interface to machine learning. And it's incredibly easy to use. I'll show you that in just a second. But before I do, I just want to highlight the fact that although machine learning used to be a priced option for the Oracle database, it's now free in all supported versions and editions of the Oracle database. So there's really no excuse to be able to take advantage of this for whatever application you happen to be working on. So how does this AutoML work? Well, you tell Oracle what business question you're trying to answer, and it will actually identify the best algorithm to take advantage of in order to be able to generate that prediction for you. And on top of that, it will actually look at your data set and identify the best data to be able to predict that outcome. On top of the right algorithm and the right data, it'll also then fine-tune the parameters to be able to get you the best performance. So really simplifying machine learning modeling, both for the novice user and even for the more experienced data scientists. But let me show you how to actually use machine learning on the command line inside in the Oracle database, because you can access all of those machine learning algorithms using standard SQL. And what I'm doing here is I'm looking to build a machine learning model to help me predict which of my customers will buy travel insurance. And I'm able to do that by taking advantage of the built-in PL/SQL package, DBMS data mining, and I'm using the procedure create model 2 inside of that package. Now, I know I want to use a classification algorithm because I'm trying to classify the customers that I've stored in my customers tables into those that will buy travel insurance and those that won't. If you didn't know which algorithm to take advantage of, don't worry. That's what AutoML is for. It'll help you do that. But once I've built my model and I've trained it on my historical data, then I can take advantage of that model by using a very simple SQL command that you see there on the screen. What I'm actually doing is I'm calling a built-in prediction probability function in the Oracle database. I'm passing it the machine learning model that we've built called Buy Travel Insurance, and I'm asking Oracle to use that model to predict which of the customers that I have in my customers table that have $3,500 in their bank account, are age 35, and have taken 2 previous cruises with us, what is the probability they would buy travel insurance? That query will return the probability of for each customer, and that will allow me to build a target marketing campaign just for the customers that we believe will be much more likely to buy that travel insurance from us. Now, I mentioned earlier on that these applications are having to generate value or insight into the data in real time. And Oracle makes it incredibly simple for you to be able to do that by allowing you to have data in memory in both a row and a column format simultaneously, so that we can transparently accelerate our analytical style queries or those insight queries by having them automatically access the data in an optimized columnar format specifically for analytics. And we can see about 100x speed up when we take advantage of that column store. And what's great about this, as I said, it's completely transparent. Your application doesn't need to know what data is in memory in the columnar format. Oracle automatically identifies those analytical queries and sends them to that columnar format, while your standard transaction processing goes directly to the row format where it's more efficiently processed. So without any application changes, you can take advantage of this in both transaction processing or in a data warehouse or data mart environment. And another key area that we're always trying to improve, of course, is data ingest. Being able to stream large volumes of data into the Oracle database as efficiently as possible, especially as we have more and more IoT-style devices generating large amounts of data. And Oracle makes it incredibly easy for you to be able to do that, because you can take advantage of our MEM optimized write capabilities, where an application can use standard SQL to insert large volumes of data directly into buffers in memory and instantly have control returned back to the application. The application doesn't need to wait for that data to be persisted to disk. In fact, Oracle will do the data persistence in the background asynchronous, so that the application can continue to run while we're taking care of that later on. And that allows us to do rapid ingests, about 25 million inserts per second on a simple 2-socket server. And what's great is that once that data has been persisted in the database, we can actually instantly begin to get value out of it by taking advantage of the built-in time series analytics that we have inside in the Oracle database. Let me actually show you that in action. What I'm doing here is I'm creating a temperature reading table, and it looks like a regular table inside in the Oracle database, except for the fact that I'm adding the keywords MEM optimized for write to that table to just let Oracle know that the data coming into this table is going to come via those in-memory buffers. Then when I'm doing the application inserts, I'm going to use a standard insert SQL statement, but the only difference is I am going to add a new hint called MEM optimized write to remind Oracle that when it sees this insert, that it needs to put it directly into these in-memory buffers and bypass the usual data ingestion procedure. And that way Oracle will asynchronously store that or persist that data out on disk, and I don't need to wait for it inside in the application code to happen. I can continue on, get the next batch of data and get that inserted. And then once it has been persisted, we're able to do real-time analytics on that by taking advantage of the built-in analytical functions inside in the Oracle database. So in this example here, what I'm actually doing is comparing the latest temperature reading with the previous one to see if the difference in the readings is within our acceptable range. If not, of course, we could always alert the business that there's an issue with the temperature changes. And I'm able to do that really quickly by taking advantage of the lag function inside in the Oracle database. Speaking of analytics, graph analytics is another incredibly useful and powerful technique at your fingertips. And Oracle makes it super easy for you to take advantage of that, whether you're looking to find an influencer in a particular community, you're looking to rank things, or get a good 360-degree view of your customer. Whatever it may be, Oracle has over 50 in-memory parallel analytic graph functions available for you to be able to take advantage of. And on top of that, we also provide an open source graph query language called PGQL that is going to allow you to specify graph patterns which are matched against the vertices and edges of the graph, making it very easy for you to be able to get value from that graph data. And just like machine learning, Graph was a previously priced option for the Oracle database, but now it's free and all supported editions and versions of the Oracle database. And let me just show you how easy it is to take advantage of this graph query language, because it is very SQL-like, and you see there in the query in gold on the slide, what I'm looking to try and do is actually find the community or the network belonging to Barack Obama. And so the query there is saying, I want you to start from the Barack Obama node, and I want you to walk out along the vertices to the different edges and find all of his connections for me. Let me create that community for him. Now, earlier on, we talked about the fact that a lot of applications are now taking advantage of storing the data as JSON documents, so we can have exactly the same representation of that data in the application as we do inside in the database. And Oracle makes it super simple for you to be able to use both JSON and XML documents inside in the database, because we allow you to freely mix those data formats and across the different data models. So super easy to take advantage of that. Now, one of the downsides of storing everything in documents is the more documents that you store, the harder it is to determine exactly what data you have. Because remember, we're able to evolve the schema inside of those documents rapidly. And Oracle makes it super easy to unravel all of that complexity, because we offer a native built-in JSON data guide that allows you to understand exactly what data you have stored in all of those documents. And of course, because the documents are stored inside in an Oracle database, you're going to get transparent scale out along with full ACID transactions on top of those JSON documents. And if you are using them in more of a transaction processing style system, that's no problem, because Oracle allows you to index the individual elements inside in the JSON document, making it really easy to be able to retrieve exactly the information you're interested in. Of course, if it's more analytics that you're interested in, that's no problem, because Oracle will allow you to run our full parallel SQL analytic capabilities across JSON, but not just JSON, but it allows you to be able to run queries and transactions across all the different data types. So JSON, relational, and spatial data can all be accessed in the same query, in the same transaction. That's not a problem. And what's also nice is there's no need for any custom application code to accomplish the very basic data management tasks, because that's all taken care of automatically for you within Oracle database. So let's take a look at using JSON inside in the Oracle database. Here what you see is that I'm creating a table called menu items. It's got two columns, one relational, which is the restaurant name, one is just JSON documents, and those JSON documents are storing information about the different menu items we have in our restaurant. And if we take a look inside one of those JSON documents, we see they're pretty straightforward. I've got an ID for each of the menu items, then the name, the price of that item, and a couple of other attributes about the item. And what's great about storing JSON in the Oracle database is it's super easy to access the individual attributes or elements inside in those JSON documents, because you can take advantage of Oracle's extended dot notation. So anybody who's familiar with the database will know that you can always access a column within an individual table by using our dot notation. So table alias dot column name. Well, we've extended that to be able to make it easier for you to navigate through the different attributes inside in JSON documents and using that same dot notation. So in the example here, you'll see that I'm querying both the price and the name from our JSON documents using that dot notation, M being the table alias, menu items being our JSON column, and then I use another dot and say which of the attributes within that JSON document I want to retrieve. And I don't have to use this technique just in the select list. I can take advantage of it in the where clause predicate. I can use it for selectivity clauses. I can use it also for joins, aggregations, having clauses. Wherever I need to use it, I can take advantage of that technique across the SQL statement, making it incredibly easy to be able to take advantage of all of the data that we've got in those JSON documents. Now, speaking of storing large amounts of documents, one of the greatest ways to access all of that data, of course, is to use text search. And Oracle makes it incredibly simple for you to be able to take advantage of searching and analyzing text inside your applications, whether that's keyword search, context queries, or pattern matching, because it's built into the Oracle database. And not only can you do that, but you can also perform linguistic analysis on documents to make it really easy to classify them. So for example, if we were streaming our customers' feedback from social media into our application, then we can classify that feedback as either positive, negative, or neutral automatically by taking advantage of the text search capabilities inside in the database. And you can also do this on JSON and XML documents and actually use the structure of the documents to limit that search. So for example, we can say, I only want to find the purchase orders, which are JSON documents that contain the keywords damage and delivered in my database. And Oracle makes it really easy for you to be able to do that. In fact, let me show you how easy. So first thing you'd need to do is create a search index on that JSON column inside the purchase orders table that has our purchase order documents. And as you can see, very simple to do, standard create index command, one addition of the keyword search, and the other addition being for JSON to let Oracle know that this is being done on a JSON column. Once I've got the index created, I can take advantage of that very easily by doing a standard SQL statement, but taking advantage of the built-in JSON text contains function of the Oracle database and saying in the where clause predicate, I only want you to return purchase orders where the comment field or attribute inside in those JSON documents contains the words delivered and damage. So very, very easy for us to be able to do powerful text searches inside in the Oracle database. Now, spatial data and location intelligence analytics, as well as map services, are also becoming incredibly critical for these new enterprise applications. We want to be able to compute the distance between places or people, or analyze a transportation or utilities network, or even just define our sales territory. And so having that at your fingertips is going to make it much, much easier. And Oracle does that just for you because we've got hundreds of in-database spatial operators and functions ready for you to use. And again, just like graph and machine learning, Spatial was a previously priced option for the Oracle database, but now it's free in all editions and supported versions. So how easy is it to use? I promise you it is foolproof. One of the ways I use our built-in spatial functions is to work out what restaurants are within 5 kilometers of my home. Why? Well, those restaurants will deliver for free. And over the last 14 months, I've been doing a lot of takeout. So how does it work? Well, what I'm doing here is a simple 2-table join. I'm joining the restaurants tables to my geolocations table. And what I've got in geolocations is literally the geolocation for my home. And so I take advantage of the built-in spatial feature, SDO within distance, and I give it the location of my home and the restaurants that I'm interested in. And I tell it I want it to return only the restaurants that are within 5 kilometers of my home. And so when that statement turns out to be true, it'll return the name of the restaurant. So I'll get a nice, neat list of all the restaurants that will deliver to me for free. Now, one of the other key things that we need to do for these enterprise apps, of course, is to secure all of that data. And lots of databases out there on the market today give us plenty of techniques to protect our data from external attacks. But what happens if we have a user that has the right credentials, but has gone rogue inside of our organization and they are looking to change or, God forbid, delete data from our environment? And we want to make sure that we can protect against that scenario too. And Oracle makes it very easy for you to be able to do that by giving you blockchain tables inside of the Oracle database. These are immutable tables that will automatically chain new rows to existing rows cryptographically. So when a new row is inserted into the table, we'll actually calculate something called a cryptographic digest for that row that is based on the values in the row itself and the cryptographic digest of the previous row, which is that link or creating the chain. Once we've computed that, then if anybody tries to tamper with that data, even if they try and do it outside of the database or underneath the database at the storage tier, we'll be able to detect it. Because when we evaluate that row, if the entries have changed, then the cryptographic digest that'll be computed for that row won't match what we originally stored, and we'll instantly be able to know that somebody has tampered with that entry. And that will effectively break the chain and allow us to know that everything after that has potentially been compromised. Now, what's fantastic about blockchain tables is the fact that they're transparent to the application. So it's going to be super easy for you to be able to take advantage of that because they look and feel just like a regular table. You can run all the standard transactions as well as analytical SQL against those blockchain tables. So let's take a look at blockchain table in action. It's incredibly easy to create a blockchain table because it looks just like any other create table command, except we're going to add that keyword blockchain to the table creation. Once that table is created, I can happily insert row after row into that table, no problem. But if you notice there, when I try and delete from the table, you'll see that that operation wasn't allowed. In fact, I get a new error message that says, operations like delete are not allowed on a blockchain table. In fact, you can't delete, update, merge, truncate blockchain tables. Why? Because they're immutable or insert only tables, and data can only be removed from them once it's become obsolete. Now, by default, the data isn't obsolete, but if you want it to be able to age out of the table or become accessible to delete, then what you can do when you specify the create blockchain table, you can specify when that data becomes obsolete and when it can be deleted. Now, what about verifying that no one has tampered with the data in our blockchain table? Well, we're able to easily do that by taking advantage of the new DBMS blockchain table package that's inside in the Oracle database. Part of that package is the verification process or verify rows, which will go through each of the rows in that blockchain table. It'll confirm that the values in the row match the cryptographic digest for each one of those rows, ensuring that the chain is intact. If it discovers one of the rows has not got the right verification, then it will return that information telling us exactly which row has been tampered with in the chain, letting us know that all the subsequent rows from that have to be considered invalid because we have a break in the chain. So before we wrap up, I just wanted to share with you just the key takeaways from today's session. Oracle wants to make it very simple for you to be able to build and deploy data-driven applications. And we've done that by providing you synergistic data paradigms for each of those new development paradigms so that it's very easy for you to be able to adopt them without adding any complexity to your architecture. And we also want to make it very easy for you to take advantage of any different data type or workload by offering you one converged database that supports all of those different data types and models, but that has been engineered for them all to work together, enabling you to get that cross-data synergy, allowing you to be able to do things like machine learning on spatial and JSON data and having all of the advantages without any of the complexity. And of course, we do really just want to simplify not just the development, but also the deployment of those applications with that converged database.